GM Dabblers, Kale Moody here, community manager at Dabl Club. I am joined by Mel. We hope that everybody had a wonderful weekend and happy Memorial Day if you celebrate it. I know that Mel's mentioned to me that he's been writing some contracts and he's ready to dive right into the technical work today. I just want to thank everybody for their time and their attention so far on the Dabl Club DevCamp. This is our fifth session now in this series, and we're really getting into the weeds. We're really getting into the nuts and bolts of things, starting to actually get the whole UI put together with the smart contracts, figure out how to turn your ideas into deployments on chain. And so without further ado, I'm going to hand things off to Mel, and we're going to get started with today's festivities.
Thank you, Kale. How's everyone? Hope everyone's been having fun, had a good weekend. Today, we're going to be moving more towards the front end. So we were working on some smart contracts last week, and today is the day that we start working more on the user flow and the user interfaces, how we want the user to interact with our smart contracts, and how can we use, of course, the framework that we are using, which is Scaffold E2, to make it easier for us to deploy contracts and just have a better understanding of what's happening for them on their their assets, their their interactions with the smart contracts themselves, the tokens, the NFTs, and also events that we can publish, emit, and also catch them and display, toast on the UI, display some information, even use it as part of an indexer. We're not going to see this, but these events, when they are emitted, how we can catch them and listen to them and inform the user that something has happened properly, and how the flow goes with their with their wallets and all of these cool stuff that we will be doing on chain. So today we will be using a repository that I've been working on. Let me first share my screen. I wonder why this repository. Okay, let me upload the contract very quickly. I haven't uploaded the code here. Should be rather straightforward. Well, okay. Forgot my password for a bit there. There we go. And let's share screen. Awesome. So this is the repository that we will be using today. Let me create a QR code for this page. And I don't know if that's large enough. I don't think so. Not at least on this part, but we can do this. QR code generator. Second one's the one that's good. So you can just scan this if you want, and this will take you to the GitHub repository where we will be using the smart contracts. They are improved versions of the smart contracts that we have been working on. So let's open up Scalidra so we can also, and let me copy this image. You can also have it somewhere here. Just copy this. Yeah. So this is what we have been working on, this whole DevCamp. So we will be, and I'm gonna leave this QR code for the GitHub. It's super small, but it's okay. So what we have improved are the real estate NFT, which now has information. We're gonna go through it. Don't worry. But this has a better, per definition of our NFT smart contract. We will go through it very quickly, just so you know what's happening. The ERC20 token, this couple of two have stayed pretty much the same, just minor differences. The real estate NFT, we are allowing it to store some information regarding the metadata. So we have it stored at least on chain in the meantime. Ideally, you have it on some decentralized storage solution, or even like a centralized one if you want, but as long as it's accessible on the internet. In the meantime, we will be storing them on the smart contracts. So that's one change that we have made to the real estate NFT token. Then we have the property shares ERC20 token. This one has stayed pretty much the same. We just added, if I'm not mistaken, a couple of withdrawing functions for assets that are there and redeeming functions. Whenever someone completes like the whole shares, they can redeem the NFT for the state. And the one that has suffered the most changes has been the ERC4626 Vault token. So to this one, we have added a couple of things. Well, mostly instead of a strategy, we will have added the monthly earning strategy. So we will be distributing this as rewards, kind of. If you've seen this probably somewhere in some other protocols where they distribute monthly rewards for liquidity mining or stuff like this. This is a very similar concept. Instead of doing it fully on chain, of course, we will be depositing a monthly earnings for, let's say an apartment has been rented, so it receives a monthly earning, or a business office is also rented, so they get some tokens, and only the users who have staked tokens will receive the rewards. So that's what we're going to build. Well, that's what we have built already, and what we have improved with the smart contracts. So if you go to the repository here, you will see that our hard hat package, or our hard hat folder, has these three contracts right now. So I'm going to go and I'm going to clone this repository. Should be able to do it. Yeah. Here, I'm going to copy this and clone it. I'm just going to put it demo. Then we move to the demo folder, which is the one that we just cloned. And let's open our folder. So, like I said, sorry. Like I said previously, let me share change this real to property NFT, so it's like more in line with what we are doing on the other ones. Real estate, okay, that's good. And so the property NFT, like we said before, we are using now, we're using ERC721 URI storage and Ownable. These are extensions that we have available. We have, okay, let me zoom in so we can take a look more clearly. So this is one thing that we have added. If you remember, structs are just another variable type that we can define inside a smart contract that allows us to create this structure, this data structure that can be defined as we want. So you can think of it a little bit like an object that you can define, and this object has specific properties that all objects that are the same variable, the same type, property details, are going to have this. So this property details is the storage, the data structure that we will be using to store the data related to the specific property. So that way, each property will have location, which is the address, square meters, the value. I'm just gonna put this value. And the property type, residential, commercial, etc. This we won't be using this as much. It's just as part of our NFT, but might be useful for our UI. And we will see between today and next session how we will be displaying this kind of flow. Then we have our properties mapping. So here, each token ID is gonna link to one of these information. So each property will have its own details. The next token ID, we have seen this is the counter. Then the constructor just initializes the counter. Here, we should probably change this to property. Yeah, that looks better. And we're using the Ownable and ERC721 extensions. So here's how we initialize them. The extension with the name and symbol for the NFT, and the Ownable extension with the owner address, which we will be passing as part of our constructor arguments. And we initialize the first token ID as 1. So whenever we mint a property, it's going to be very similar to the mint function. Here, token ID is going to be 1 more. And so here's going to be 2, probably. This is not desired, but Oh, but no token ID plus plus. This is 2 because it's 1 here. Then it's going to assign this property to number 2. Yeah, I like that. So this will probably need to be moved. Property, then we mint it. We'll use the inherited function from ERC721 URI storage, which itself is also an extension of ERC721. Why can't I open this? Okay, maybe I need to install. Yeah, I cloned it, but I didn't install the dependencies. My bad. So we can access all of these packages, such as OpenZeppelin and extensions, so we can review them, but we'll review them in a bit. So we'll keep going while it installs. So remember, we clone it and we run yarn install first. Right now we're reviewing the contracts. So it receives information related to who is it going to be minted to, the location, the square meters, value, and property type. All of these are part of the struct that we will be defining. And the token URI, as you remember, is like the URL or URI where we will be storing this information. In the meantime, we will be leaving it empty, and we will be basing off from this information. Then whenever we run the mint property, we assign to this specific token ID the new property details. So these are all from the function call, and then we use the extensions, like I said before, which should be available now. Still haven't installed. It's done. I'm confused why it's this. Maybe if I close it and open it again. Had a typo here. There we go. Now we can watch it. So like I said, the ERC721 URI storage is also extending ERC721, which has the mint and which was the other function, the mint function, and the other was the token URI function, if I'm not mistaken. Set token URI. Oh no, this one's from this extension. So these are the two functions that we're using to mint the property. The only thing that I really want to do is I think this there's a small mistake here with the token ID number, but we can let it go by. In the meantime, some functions to get information, get property details, update the property details in case that we want to increase the value or change. I mean, I don't know why we would change the location, but the property type can be changed. Delete property. These are just like normal functions that we use in web development too. You know, create, read, update, delete, or rather web development, but just you know, whenever you build like a CRUD app, that's what we usually do. So create, read, update, and delete, and then just checking if the token ID exists. So this is a very basic implementation. The only difference is we create or add these property details, and this is the one that I'm willing to move. Now we're reducing this. So the token ID gets, we're gonna leave it like this. I'm pretty sure this is gonna start at 2 because this next token ID is 1. So the first one is gonna be, it doesn't matter. Let's leave it like that. So we have checked the property NFT token. Now we're gonna check the ERC20 token, which is also, you know, very similar. We are inheriting the ERC20, which is the one that we will be using. We are using the ERC721 holder because at the end of the day, in order to mint or create this, deploy this ERC20 contract, we will be using this extension to receive an ERC721 token, which is a representation of the property. And this is just a receiver extension that you know, returns where the selector for the ERC721 receiver. So it kind of just mhm, transfer to transfer in. So in other words, this allows the contract to receive an ERC 721, because sometimes if you don't code that into your smart contract, it can get deposited, but sometimes it cannot get withdrawn. So that's something that we need to take into account. Ownable, we have seen that, and reentrancy guard. These ones, this is kind of like, how would I explain it the easiest way? So a reentrancy attack is whenever it's like you open a door and you leave the door open. So imagine there's a vault and you identify yourself as the owner of some money that's inside the vault, like in a bank or something, and you give this you're a holder of some money, right? And you give permission to somebody to access some money for you, that you want to withdraw some money. However, with the reentrancy attack, what happens is whenever you call this function to withdraw some funds, you kind of leave that door open, and a malicious attacker can work on that same function that you have applied and keep it running on their contract, just using the same function for withdrawing funds. But inside their contract, they will keep draining funds from it. So it's like leaving the door open and not closing it. So what the reentrancy guard does is just kind of like a toggle between the values if the function has been called or not. Kind of, you can think of it entered or not entered into the code. If it has not, then it allows it to run, and if it has, then it doesn't allow any other code to run. So that way, whenever you have entered or opened the door once, nobody else can come in and re-enter the door. That's why it's reentrancy, and start draining funds. So in other words, what happens is first it checks that the status is not entered, because if it's entered, then it blocks anyone else that wants to keep making calls with that first call, with that first function call. And likewise, the non-reentrant after, whenever it finishes, remember this this syntax for Solidity, that it indicates that all of the code that's after the modifier can be run, and then after all of the function of the modifier runs, then we run again this small function, which is the non-reentrant after, and it just kind of closes the door. So first you say, hey, I'm entering, I'm turning on a flag that says don't run any additional code, because it has already been initiated, the process, so you can only withdraw it once. And if you finish the whole function like this, you can withdraw you can close the door and say, okay, now we have finished, you can do whatever you want. I do recommend to dive a little bit with ChatGPT, explain like I'm 5. It also is very helpful in case I wasn't clear enough. But in short, it's just an inheritance for security. So some definitions that we had previously, it's the NFT contract that's going to be receiving as part of the share. So we will link this to our property NFT. The NFT token ID, which is each ERC20 is going to be linked to just one NFT token ID. So one for each property. This is just so we know if the NFT has been, once it's deposited, if it has been redeemed or not. The total amount of shares that we want to the max supply that we want to make available. This is just to keep the balance of the total minted shares. Property name, this is just for clarity. Share price. We're going to start this session in Way. Next session, we will be switching to USDC so we can track with stable coins or other ERC20 tokens. But in the meantime, just to make it easier, we're going to start with Way. Maintain enable true. This is just like a true false if we want to allow, kind of turn down the contract. And this address for treasury in case that we want the funds to be sent to a specific address. Events. These are all events related to the functions that we will be having. The fractionalization of an NFT, which is like whenever an NFT is minted, an NFT token is deposited and the shares are, or rather the ERC20 token is created. This is going to happen in the constructor. Over here, yeah, the constructor. The NFT redeems whenever the kind of like closing out this shares token because the NFT will be withdrawn. Shares purchased, very self-explanatory. Share price updated, minting status updated, treasury updated, and funds withdrawn. All of these are pretty self-explanatory. And then to the constructor. So here are all the variables that we will be passing for each ERC20 contract, and the NFT contract for the property, the token ID that indicates each specific property, max total amount of shares, the max supply, the initial shares for the owner, the share price, it has to be in way, and the property name. And lastly, the treasury. Over here, you can see that we are using these for the name and these for the symbol. These are just ways to encode strings into what, using the encoding it into the bytecode that actually is going to show this information, shares of the property name. But since we don't have like spaces or we not necessarily have this property name defined, we're using the ABI encoded pack first call, and then we initialize it as a string. So this is just like a weird way of encoding and then using it as a string from this property name. Likewise for the ticker or the symbol, and the ownable is going to be for the sender. Actually, here I think I'd rather have address owner and switch it here. Yeah, I think we did that also in the previous ones. So some requirements, make sure that there are no more than the amount of shares required, or more than 0. The initial owner can't have more than the total shares. The share price cannot be 0, and the treasury address cannot be 0, and also the owner. Let's just keep it there. Then we initialize the NFT contract. We typecast it to an ERC721, which is this variable that we defined at the beginning. Then the NFT token ID for this token, all of these variables, we pass it along. Then the first thing that we do in the constructor is precisely call the NFT contract, which is the one for the properties. We're going to make a safe transfer from where we will be, whomever wants to start this property shares token, they need to own, of course, the NFT contract, and they will send from them to this address that NFT contract, or rather that NFT token or NFT property NFT. It needs to deposit it into the shares token. So that's what's happening here. We have initialized our NFT contract variable with the address that we are passing in the constructor, and then we call the safe transfer from the sender to this address, and this is going to trigger this safe transfer from should call the allowance. Yeah, safe transfer from seems safe. So we need to approve this approval event as well, if I'm not mistaken. Okay, we'll check it in a bit. Then if initial shares for owner are larger than 0, then we mint to the owner this amount. So first we, since this is gonna be the first minted shares, the same amount is going to be assigned as a total supply, and we will mint to the message sender this as an owner, the initial shares, and we're just using this for the decimals because we are using way, remember, and we need to set the decimals to 18, which is what we're doing at the bottom. Decimals are 18. And we made the event. Then the share amount, the purchase shares, it's gonna have very similar requirements. And the only thing it's doing is calculating the amount that the user wants to buy with the price, and make sure that the value is larger than that or more. Then we update the total supply, and then we mint it to the user. And these funds that we are receiving as part of the message.value, so we are going to we're going to pass along this this total cost amount we're going to pass it along to the treasury. So the treasury is going to call this which kind of withdraw function, or full success treasury.call. This is like it's just a transfer function. So what we're going to do here is send the message at value amount to the treasury. And lastly, we will refund the excess ETH in way or whatever that the user has sent. So we just calculate the excess, and if there's an excess, we will call to the message of sender. We will send it back the amount of refund. Then we will emit the event. The new share price is very similar. We just update the share price. The status for the set meeting enabled, like we said, we need to initialize this contract. Probably going to initialize it at the beginning in the constructor, so we'll change that in a bit. Update for the treasury in case that we want to. The owner can mint shares whenever they want. This is, I'm just gonna put in this here in case that we need to mint some shares without having to buy or whatever. Then the redeem NFT is to withdraw the NFT here. We have to burn all of the tokens, set the is redeemed to true, and we transfer from, now this time we send back the NFT to the sender or the owner. Ideally, this one, well, the owner will be here, perfect. We require them to have all of the shares. So that's one of the requirements here. We need to require that the NFT has not been redeemed before, that we have all of the shares have been minted. So the property value is already in liquidity, and that there's the person who's calling the redeem NFT actually has all of the shares. Otherwise, they cannot call it. And if everything goes well, we emit the event. Lastly, withdraw funds. This one's also like very, very simple. Nothing major here. And just a couple of functions for the decimals and the available shares that people can withdraw. So that's the latest contract for the ERC20 token. And now let's move faster to the shares vault. So here we are using, again, the vault ERC4626, ownable and remittances guard as well. Some functions for the rewards configuration. We will, since this is the idea, I mean, we're calling it the rewards just that because that's like the word that we are most familiar with inside the on-chain ecosystem. However, this can be thought of as the rent, the money that the property is generating. So it's distributed every 30 days. So this is a lot, this is very manual, this contract. So we need to define some configurations for the rewards, the period finish, when's the last update time, the reward rate, and the reward per token stored. And actually, this should be okay. Perfect. A couple of mappings to keep track of our user rewards. So this is the rewards is the current kind of total amount paid, and the user reward per token paid. This is like the balance that has been withdrawn. So kind of like keeps two. We'll see in a bit how exactly this works. Events, reward added, reward paid, and strategy yield generated. So what's the amount of money generated, the reward that has been paid, and then the reward added. The reward added, that's when the administrator of the building or the property deposits some money, and we will emit this event when rewards are added each month. The reward paid whenever any holder of this token has claimed the rewards, and this strategy yield generated. I'm not sure when is it called. I don't remember. Yeah, this is for the okay, just for the it's a placeholder for the yield for DeFi protocols. Okay, so the constructor, first we receive the asset, which will be our property shares token. Then we initialize it with 4626, the ERC20 as well for our vault tokens, and our message sender. And I'm going to put once again sorry, it's not here. To put the owner here as well, just so we control that specific address. Update reward whenever we update the reward per token. total assets equals 0, return reward per token stored. So here, this first reward per token stored, okay, yeah, let's go step by step. Okay. So first we need to get the reward per token store and the last time reward applicable. This just makes sure that you are log timestamp, the current timestamp. And reward applicable. This kind of like just making sure that the reward is not larger than the period, that that the period hasn't finished. Yeah, let's not log down with that. So in short, what we're calculating here is how much we are assigning the token that it's deposited, how much we are assigning it rewards. So if there's 0, it's gonna be like the base value that has been indicated. At the beginning, we're probably gonna set it to 0 unless we want to give some additional amount for some reason, but that's not like an ideal thing. And if not, like if the total assets is larger than 0, that means that people have been depositing into the vault. Then we will be sending this base amount by the last time reward applicable. This is per user. Timestamp period finish. It just calculates between the last time the rewards were available and this current time. It just gives you a period of time that is going to be multiplied by the reward rate, and this is for the decimals, divided by the total assets, because it has to be last time reward applicable. Yeah, okay. So the calculation for this value is going to return us how much each token should be receiving per of rewards. So this is like the general value that we need for anyone who wants to calculate how much they can receive. It's going to be calculated by this formula. So each token will be assigned a portion of this reward, assigned according to this token, this reward. And the reason why we have this is because this value can be changed. So whenever this, we'll see when we get this reward per token calculated. So whenever a user wants to calculate how much they have earned, it will get the address of a specific, the balance of a specific wallet, and use the reward per token to calculate how much it would have, according to their balance, minus the user reward per token paid, the amount that has been already paid to the user, divided by the number of decimals plus the rewards of the account. Okay, the deposit, that's using still the 4626, if I'm not mistaken, as well as the withdraw. We're just defining the overrides. And the get reward, it calls this modifier get reward. Yeah. So every time a user deposits any tokens, we need to calculate this reward distribution, because these rewards, whenever I deposit some money, I change the distribution of how many tokens I have compared to other users. And since we only have one monthly pool of rewards, let's say the rent is $1,000 a month that we receive as owners, since it's going to be distributed, between a lot of people, which may have staked at different times, at different points in time, we need to calculate these rewards periodically whenever somebody deposits. So that's this modifier, what it's called. So it first calculates this reward, then it checks the last time it was updated, and if the account is not 0, which account? this account is going to be it's an address that's always either the owner or the message sender, the users that can interact with this, and except the address 0, which is called here in the add monthly rewards. So if the address is not 0, which means the address 0 is only called for the update reward whenever we want to add monthly rewards. So this shouldn't be called whenever the administrator comes and deposits the earnings of the property. So whenever we run that function, that's why the address 0 is called. It is used as not a default, but like a specific case that we don't want this function to be called. So this is kind of like a mini hack on how to distinguish this call. So we can call this with the 0 function whenever we don't want this function to be called. We just call it with the address 0. However, whenever a user or the owner calls the update reward, either it is because they deposited or they are withdrawing, we need to recalculate these rewards. So first, we are going to assign the rewards to that user, to that specific user. We're going to calculate these rewards and assign it to their account. And we will user reward per token paid. We're going to assign this value to the address. To this variable. However, this confuses me a little bit. User reward per token paid, the account to this account. So first, we calculate how much rewards they earn, and what I'm wondering is why we have these two functions, but I'll keep it there in the meantime. Earned, deposit, we are also checking that update reward, and all of this. The add monthly rewards, like I said, these ones for adding, only the owner can update rewards, okay, add monthly. So here, these are just like in case the user, the owner adds more rewards in a different, not in this, not every 30 months, not every 30 days rather, but instead it adds more rewards in a specific moment. So if it's if the period has finished already, then we kind of just calculate the rewards from 0. However, if not, we will need to do like a recalculation whenever there's additional rewards added. And whenever there's a reward added, we update the last update time and the period finished accordingly, and we emit an event. And this generate strategy yield is for DeFi. We're not gonna touch it at the moment. So those are our 3 smart contracts that we have improved. Took us almost 4 minutes to go through them, but that's good. So we will go to our terminal. We're gonna need here. So let's first here, we need to update our scripts to deploy. So I'm gonna copy this a couple of times. Let's call this 01. And this 02. And the first one needs to be the NFT token. So for this one, I will use, I think we probably need to use, I'm gonna use this one. Just because I need the wallet address to be simpler. So let's use this wallet. Have some tokens, yeah, that's gonna be fine. And that's the one that we will be using as part of the agreement. if I'm not mistaken, the NFT and the ERC20 token, both of them only need the owner as a constructor argument, correct here? And ERC20 token, oh, sorry, constructor. The owner as well. Actually, this one needs a lot of information. So the NFT contract, we will be receiving it from the previous deployment. The token ID, we can just give one. The max total shares, we can say 1,000. Initial shares for owner is also arbitrary. All of the rest are arbitrary. We only need the treasury, the owner, and the NFT contract. And out of those, the NFT contract is the only one we don't currently have. So you can probably, I'm going to comment out all of that because I just want to deploy the property NFT. Just because remember with hard hat, we get that token symbol. We get kind of like the same address whenever we deploy it because it's very programmatic. So that's why I'm doing this. So I'm going to check what's this address that it usually deploys the check the version. Okay. So we need 22.14. Okay, now we're running this, and I'm going to run the deploy down here. So again, I'm using the wrong version of Node. Run deploy. I just want to have the address first for the NFT contract. We have a small issue. Oh, yeah. I need to remove these files. I'm just gonna switch them from folder. Yeah. So we actually deployed correctly here, the NFT, so that's great. And we just need to grab this address. Okay. So let's switch back our scripts here. And now for this one's gonna be the property shares token. So here first we need the smart contract address. Then we need a token ID, max total shares, and initial shares for owner. Let's just put token ID 1, max shares, and here I'm gonna put, let's say 100. And remember, we're going to do parse ether. Yeah, 100. So parse ether receives a decimal, which represents ether, and it transforms it into big int. So this is going to be transformed in two-way. Then we need max total shares. That's what we just did. Initial shares for owner, share price. For the owner, we will have, let's say, 25. Then price per token or share price. Let's just put 0.1. Just in the meantime. So how many tokens we're gonna have? No, it's gonna be, yeah, it's gonna be very cheap because if we're gonna have 100 tokens and each token is gonna cost 0.1, then the total cost of the property is gonna be 1. That's okay. Let's just let's just keep it like that in the meantime. Then we have property name, treasury, and owner. So yeah, property one. The treasury and owner, we're gonna use the same wallets as this one. And that way we will have our shares token ready to be deployed. And we just need the last one, which is the vault token. Shares vault, and this one also is only the constructor, right? The owner, and also the asset. So we will need as well the next one. So let's say we kill this, we run it again, and then we try to deploy again. We're gonna get the first and the second one correct, and the third one should fail because we haven't changed some things there. But we should see at least our, so property was correct. Actually 0.1. Okay, that's the issue. We're trying to mint, okay. Okay. So we can try to mint first. Like we need to do this. Wait. No, we can just do your contract. There we go. You can just, but actually the mint property needs more. Of this. And so this one, so this one. So the address 2, we're going to use the same as the owner here. Then the location, we actually need, let's see. Yeah. Square meters. It's a unit, so that's just 100. Value. So this one says it costs, let's say it costs 200,000. And property type, residential. And the token URI is the one that goes at the bottom, yeah. What else can we access here? Yeah, we can use the token URI. Let's try it now. Ownable, authorized, unauthorized account. Oh my. Just put this that anyone can mint it, just to make it easier for now. Still the same? Yikes. Oh yeah, I'm into. Wait a second. So I removed this. So anyone should be able to mint. And here, when we try to mint, I think I'm not compiling and compile. Onchain. So here it doesn't seem to be registering that. Well, we're saying that this one's the owner, but the mint property should be available to be called by anyone. Yeah, this one's not. Yeah, this one's not. Deploy. Okay, now we have it. So we are generating correctly this part. Then on the 0.1, we have insufficient approval. So we need to approve. Like I said, whenever we want to, for the 0.1, since we are calling on the property shares token that we need to transfer the NFT contract, we need to approve it first. So this is something that we need to do here. So if we're minting it to, I'm gonna have to mint it to myself, to this deployer instead of this owner. Deployer. Actually, I think we can also. The problem is that if we don't do that, we are not going to be able to. So we need to do that approval, okay? So wait, no. Proof. Because on here, which was the address for this one? The issue is that we don't know which is this this function. This not this function, but this address. So maybe we're trying to do it to the properties NFT is correctly deployed. From data, yikes. Let's try to the shares token. Just want to remove this in the meantime. Just to get the address. Here's the property shares token, transaction deployed at this. Okay. So, like I said on the here, approve deployer. Now we need to approve to this one. I think this is a token ID. So let's see now. Kill this. And since we have approved, then now we can turn back this. Okay. I think we're still having the same issue with the property shares token correctly deployed. And we were trying to read your contract. Okay, that's okay. Nice. So we have this one finished. Let me remove this on the bottom. We are not using any of this. Remove this as well. Let's say, yeah, Draw supply. Okay, and then the last one that we need here, the property shares vault. This one needs the asset and the owner. And the asset, we have it here whenever we are deploying our property shares token. This is the one that we will be using, and we need to put it here. And also the owner. Apparently we're using the deployer for all of them, right? Maybe I'll use this one for me. Because there might be some. Then it's called again to supply. Oh, okay. My bad. I just don't have the total supply. But we can get, let's say, should be a total supply, right? Function, decimals, asset, total assets, my bad. Okay. So let's kill this again and restart over here. Deploy. Now everything should work fine. Get a small error where, whoa, this one's large. So we had worked through that property. There's, yeah, I think I'm skipping too much. But this is all data. Okay. So the token is correctly insufficient approval. Am I not approving it again? Wait, approve. So the NFT works correctly, but this is confusing me a little bit. Let's try again. Turn this one, which is larger. When trying to deploy the property shares token, we had gone through that one. Property one JSON symbol. Insufficient approval. Your contract approve. It's had worked before, right? Pretty sure. Token ID could be an issue. Because we're doing one, but remember this thing here. It's what's crazy for me. Could that be the problem? And deploy. It seems like we're still getting the same error. Insufficient approval. Why is it trying to get this one? Okay, this one's okay because we're using, I feel like I'm getting different addresses now. Could that be it? Let's see. first we successfully deploy at this address. So right now property is deployed correctly, but now it says ERC 721 unexistent token 1. Oh, it's here, okay. Okay, so the token ID thing is not it. That seems to be working fine. Now we should have our previous error before, where we actually log in the symbol as well. And then, yeah, the URI. The problem is that we are not authorizing the approval correctly. So yeah, let's take another look here. It's on property shares token here. This is the one that's causing all of these issues. So the NFT token ID should be okay. That there's the sender, this is the problem. So the sender should be the owner of, I don't know if this is a problem, but it's worth taking a look. Here the sender authorizes, no, not authorizes, calls from the sender to the address. So the sender has to have those tokens, which is correct. We are minting it to the deployer, and that the sender is approving to what's supposed to be the next token deployed, which is this address. Let's see. Oh. Approved. No. Let's see our ERC 721. Okay. They're approved, it's fine. Returns Boolean, returns address. Okay. So this one just checks that this could be the incorrect owner. No? Zero, anyways. So really what I want to check is get approved, so we can just do get approved. I want to check. Owners, balances, token approvals. Yeah, this is the one that I want to check. Get approved for 1. It's this internal or something? Yeah, we can call it, okay. But we cannot call it is authorized is also internal. So we'll need to put it on our contract, I guess. We will need both of them. This need to be overridden. Yeah, just so we don't get like, yeah. Quickly, and let's see on our deployment for the first one. Where is it now? This one. I think that should work. Kill once again the chain, and start to deploy once again. So this one's actually approved. However, try with this one. I'm not sure if this is something that is required, but not sure if that's an address that's actually the one doing it. To get approval works correctly, so we get 2 approvals. The problem is that I'm not getting that. Sure. The shares token. Let's see if I can do this. This is one of the kind of things that we can do. Because I'm worried that the approval is not getting registered to the address that's supposed to be executing. I don't think that's going to help either, but reusing property. This still is not working. This is the address that it's trying to use. Let's try again. Now, this one. See, but we're getting, that's the problem. We're getting like different addresses, so we cannot get this approval ever. Okay. Let's remove the approval from here, and we're going to need to initialize this. Okay. So we can just take this. As long as the other ones are correctly set, we can call this function initialize. So let's see. So first let's abstract this transfer thing, because it's very it's very annoying. So we're not going to do the transfer on our calls because we are having some issues there. Here we can just use the variables that we have. Initial shares for owner. Where are they used? Yeah, let's put this here then. Mint 56. Is it not? Yeah. Okay. And whenever that happens, we just emit. Okay. Yeah, we can do this. An address. I hadn't seen that this was the case before. Was it? Let's see. Oh, because it's stored as yeah, case received as an address. Okay. Sorry about that. This and okay. That way, whenever we want to actually initialize the shares for owner, and we actually, sorry about this. I want to keep that transfer, but we're going to actually require it only in the initialization here. And yeah, it's precisely. And actually, it should be just a token ID because we have it here. Yeah, like that. And now we should be able to go. So now we should be okay to deploy, at least for the first two contracts, which are the ones that are causing us some issues. Total supply, perfect, we have it here. And now the issue is on one of the deployment scripts, we're using this one should have something here that we don't actually need. And then for 02, what are the addresses that we're getting? F69 property shares token. It's actually this one. And property shares, deployer, initial contract votes. Okay. Actually, we might need this. Okay. Save. Stop. Restart the chain. Deploy. Okay. There we have it. I want to take a quick pause here. And Kale, I don't know if you can take some questions and I'll be right back to take a quick pause and take a bathroom break.
No worries. Go ahead. Take care of business.
I'll be right back. But yeah, you want some questions that somebody might be answering. I can also start listening on my end.
We're all caught up right now. Yeah, Shrudi's got some good ideas that she shared with me in Telegram that I won't share publicly because those are her good ideas on projects that she's trying to build out. But yeah, I'll yank you here off real quick. You just throw yourself up on stage when you hop back here. All right, folks. So I hope you've been following along with Mel. Like he mentioned at the end of last week, this is when we get into the more difficult part of the project. It's one thing to draw out your Excala draw and ideate on the workflow and figure out what it is that you're trying to build and what it looks like and how it's going to all link together. But once you start getting down into those details and you open up that IDE and you start actually coding it out, you realize that the vibe is work. The vibe is difficult. These are not things that you can simply ask a AI assistant to whip together for you simply and have it work out of the box without issue or concern. There's so many different pieces that have to link together and work correctly. And we haven't even started really on the UI front end stuff yet. So this is all still just on that back end of the smart contract. And this is why smart contract engineers are their own dedicated role. It's some people that are spending a lot of time to become experts just in making these parts work, because by no means is it easy. So Mel, I think we got you back here, huh? Oh, get that mute off there. Rookie move.
Yeah.
There you go. All right.
Okay. So now that our deployments are finally done, that was longer than we wanted.
It's not,
But
like I said, man, it's not easy. That stupid address switching thing, that was unexpected.
yes, there's like different things that, I mean, we're trying to do. The ideal way to test it wouldn't be like this. I think we should run some tests and actually check that it works. That's the best practice. Sadly, we're not doing it like that. We're running a little bit faster than that, but okay, we have the deployments.
Well, and just a quick question for you there. Have you done any experimentation with using these AI coding agents to help with the testing part of these contracts?
They're usually pretty good. It's more on the having like a full protocol idea working and getting your proper like ideas turned into tests to actually check what you want to do. But the couple of times that I've done it, it's actually pretty decent at that. You know, you always have to tweak some stuff, but it's better than nothing for sure.
All right. So what are you getting us into now?
So for example, I mean, this is like a test that we can do. But right now I want to show, first we need to switch to the hard hat. Get some tokens. And these are all the 3 contracts that we deployed, right? So now what we want to do is we want to start creating these interfaces with Scaffolded 2 that will allow us to create, and we're actually gonna run out of time. It's gonna stop at 12:45 my time, so 25 more minutes. We're going to set up everything for the UI generation. So this is the like debugging interface that Scaffolded 2 gives us, right? And as you can see, we have connection to our smart contracts completely, where we can check the variables on the left, get the smart contract metadata also on the left, and then the read and write methods for our contracts. However, this is not the kind of interfaces that our users will be necessarily using, especially, you know, if a user reads this and gets the UINT 256, gonna say like what, and you know, handling all this information is not necessarily very user friendly. So we start thinking on the interfaces that we want our users to actually use. On one hand, I will say that just from the building blocks that Scaffolded 2 gives us, we can do this very fast. So here's what we're going to do right now. We're going to design a couple of interfaces that we will be using for our website. And now we will move to the next JS, to the front end, or yeah, the web development side of our project on the next JS application. And I'm gonna give like a very quick fundamentals. Maybe we should start with this today, and we will start with the coding next session, at least so you can understand how Next.js works, in case that there's somebody who hasn't really used it as much. So let's put 100%, and I think I had one before, like way before. No, this is not it. Okay. So I don't think I have it on hand, so I'm gonna have to build very quickly. So we can think of our development. I'll put it here as third party. Usually we have like these 3 big building blocks in our in our development whenever we're working with web applications. So we have an interface, which is a user-facing component. So that's usually an app, either mobile or web. So like Excalibur is a UI. There's a server that works all of the logic. Ideally, logic, integrations, and persistence. And that's part of also like what the database does is persist data, right? And also the server usually does a lot of the integrations with third parties. However, recently, we've also seen like with the explosion of reactive web applications, also a lot of UIs handle these integrations. With like an integration that we can definitely think of is, for example, here we have integration with a third party, which would be a blockchain, e.g. blockchain, AI models, even image storage, any kind of service, authentication. A lot of them can be handled only by the UI, but it's like best practice to have it handled by the server. And then a database, which is like a third thing that's mostly useful for internal data storage, as in the UI usually doesn't communicate with the database at all. So this kind of work that we need to do, previously you had to handle like different frameworks and different components, which you still have to use different components for each part of the like three or like the two largest. This is usually known as the front end, and this is the back end. And you had to handle a lot of the routing and a lot of the the file management that gives this interaction between the UI and the server, this back and forth. You had to manage a lot of that. So as web development has progressed, there are frameworks that help us abstract a lot of this exchange, at least on this side. And that's more or less what Next.js does. Next.js allows us to handle a backend and a front end. We only handle like one server, which is takes care of all of the distribution for the front end and the back end. So we can have, send these kind of interfaces to the user. So this is mostly on the front end, on the client. But we can also get some functionality that we might require on the back end. For example, here, our backend is helping us to get this information from the smart contracts artifacts. If you remember the ABI and the bytecode, so it's the framework is loading the backend these smart contracts. So these ABIs, it's making it available on the framework, so we can easily get all of this information and display it on the front end. So that's another integration that the server is doing. How does this look on the code? So this is the Next.js folder inside our root folder. We have packages and all of this. So inside packages, we were previously working on Hardhat. Now we are exploring the Next.js folder. And most of the action for Next.js implementation for the web app happens here in app. So this is like the main folder where we will be declaring our front end and back end, kind of components will mostly be handled here. At least this is like the entry point for the user. Then we have other folders that help us. This one, components, is very specific for front end components. We see some things. The namings you will start to familiarize. If this is your first round using code, your first time using code. So there are some basic building blocks. For example, at least on the front end side, we have things like footer, header, which are UI components. This is the header. It usually includes an app bar and something might include something else. Nowadays, it's usually just the nav bar and some metadata that is not shown here. Then we have the main, which is like this huge block that we have here, where all of the main content is happening. And usually if you have a footer such as this, that, it's just a building block. As well, we have things, providers, that you can see some names here. With providers are, are components that inject data from outer sources into our application. So one of those would be probably the blockchain provider, for example. This one, we are getting information regarding the balance, in this case, of a local testnet, but it could be a mainnet, it could be Ethereum mainnet, could be Polygon testnet, whatever. Also, the information regarding the user, its avatar, if I switch to, all of this stuff, it's being provided by a provider, a component that's actually handling all of this information. And you can see here things such as Wagmi, which is something that we will be using for the Web3 services. This query client is another that helps us handle information easier. There's a lot of stuff here, but it's also like something that you should be starting to get used to. Another one is the Rainbow Kit provider is this connection button that's very easy for us to just click and connect to an account, to an address. That's also a provider. It's been provided by the Rainbow Kit provider, and we create this like huge provider component, which is this one, that helps us handle all of this. So that's a components folder. Contracts, this is something that is handled by the Scaffold framework. So whenever we, like you can say, this file is auto-generated by Scaffold ETH, you should not edit it manually or your changes may be overwritten. Why? Because whenever you deploy a new contract on Hardhat, like we have been doing here, with all of this stuff and this chain, it also detects it here. So as you can see, we have this 31337 is probably, I'm like 99% sure that's the Hardhat chain ID. But if we were to deploy these smart contracts on, let's see, on Amoy, then we would have like a small, so 180002, if I'm not mistaken. That's what would show here, and that means that the contracts that we're deploying into that network are being loaded into our package. So that's what this contracts is, and you can also add external contracts here. The hooks, this one is it's custom. It's something that it's not necessarily part of Next.js, but it's very used, for example, on React, which is what Next.js uses on the front end. Specifically, all of these like component building and interactivity is React, the React library, and you can use hooks with the React library. And you should take a look into these hooks. It might be a little advanced if it's your first time using code. If it's your first time, don't worry too much about this. If you have used React a little bit, I would suggest, and you're like a Web2 developer trying to get into Web3, take a look into how they use the Wagmi hooks specifically, which are very useful. They use read contract, use block number. For the write contract, you also have this use account, use config, use write contract from Wagmi, because it can give you like a good insight. And we will be using this to build our components. Some of them are already built into the components, so we will take advantage of that. And the node modules, if you remember, these are the packages that we install. We don't need to take a look into there. Public folder is where images and other stuff are usually stored. So this is by default, some images that Scaffold team and the manifest file comes. Services, this is also like a custom folder. In this case, we are having a store, which is like a storage layer on top of our application, to handle minor things such as, okay, who is the user that is connected, things that don't deserve a database, but might be useful for our user flow. Usually, you will probably, if you build a web application, plan to have, 50, 100 users, it's a lot for better user experience. If it's your first time, here what's been saved mostly, it's the native currency price. So to do this kind of change here on top, or to keep this value here and it being updated every X amount of time, since it's data that we don't necessarily need to store on a database, but it's useful for our users, it's what we show here, and that can be stored in a storage or a store. That's what's usually called, and they're using Susan, if I'm not mistaken, which is very cool. And it's just mostly to get like stuff. For example, if you user and you have information from your user or information from a shopping cart, you could also store that information. Web3, these ones for the Wagmi services, for the integration with the blockchain. This is handled on the front end, so that's something important to keep in mind, at least for this scaffolding too. Styles is more for styling, so there are some things. Scaffolding 2 uses this library called Daisy UI. So it's actually built with Tailwind, and I don't remember what was the other one, but it's actually very powerful. I prefer a little bit more CN, but Daisy is very good. So you don't really need to touch this part unless you want to do like change colors or stuff. This type is not useful for you, and the utils can be useful. It's mostly if you want to check some code. There are some fun things that you can take a look into, like the block one. Not mistaken. These networks one, for example, like if you want to take a look in how they do the colors for the hard hat or switching chains, all of this stuff. It's mostly utils, but there are some interesting ideas there. So that's like the structure for Next.js. And really, whenever we want to start doing things on Next.js, we will be doing either a UI here. So here we have our, previously were called pages, or we can think of them as pages. And that's how it was defined previously. So the pages, and you can also have app routes. So pages are usually interfaces. So these are user-facing interfaces. And the routes are just API routes to interact with app. And for our application, we are not really going to be using a lot of these routes because we are not handling a backend. We are not doing a database, but we will be creating interfaces. So let's say we want to create, let's put it on top, the NFT. So if we want to do that, the easiest way to create a new page on Next.js is to go to our app folder. And of course, this is taken into account with the new architecture, which is the app folder architecture. Previously, we had the pages architecture, which you might have seen before. It's not used anymore. Well, it's used sometimes, but I don't even remember anymore how was the difference for the routes. The routing was, it's not important right now, but you had to use a different way of defining each element. Now it's mostly about defining a folder, and you can call these, let's say, property, the properties folder. And if I create a page.tsx here, and I just tell the AI, create a placeholder page for the property NFT and token creation. And here's where we're going to do a little bit of vibe coding. I'm going to add this and also this page. It should include a form for the NFT property information and a mint button. Use Daisy UI. So all of this that I'm doing is about coding. So I'm telling this agent, hey, please create a placeholder page for the property NFT token creation. And I'm indicating inside the context the property NFT contract that we created previously. And I'm just adding this page so it knows that it has to create this on this page because sometimes it tries to create a new page or does crazy stuff, and happens more than you think. Then we're going to create, we're going to add the documentation for Daisy UI to the docs. So where was my documentation for Daisy? I think I closed it. Daisy UI. Let me see if we have like an intro. Yeah. To copy the URL, and we go to the bottom of here. If we want to add to Cursor, we enter add docs, and then we go to the bottom because we have not added Daisy. We press enter. This is the URL. It's actually using HTTP. Oh, it's not. Let's. I don't know if it's gonna work, but okay. Because it didn't add the HTTPS. I don't know why. But I'm telling it, okay, just add me a form where I can enter information for the NFT property and the mint button. So that's the only thing that I am asking the agent. After that, so let's move to our diagrams. So we're gonna need an NFT creation website, NFT creation minting. Then we also need to create the NFT fractionalization UI. So this is where we create a shares token. Then we need our sorry, vault deposit, and then here's a deposit shares, receive these shares, and we also need a last one, which will be our rewards. Vault admin. Just gonna put deposit rewards. Maybe we can put it here. Vault withdraw. Withdraw these shares, receive shares. Not, then it will be deposit. And we also need the, I'm gonna put it here on the side, vault rewards. So we can deposit rewards and also receive earnings. Papers. Okay, so we're gonna need this kind of 5 UIs, 5 interfaces. Put it like this. And how are we doing on time? We're almost done. No, by default, stop. It's taking too long. Shouldn't be this long. But it's kind of reading all of the, okay, nice. It's kind of reading all of the existing folders, and it's generating the website. Just put up accept. So, you know, I did this very quickly to show how did we ask this. And the cool thing is that it's actually using components that have been built by the scaffolding team. So we go to this, remember, we created a folder called properties, and then inside we created a page, the TSX file. So this is now accessible in our Next.js application by just going to that URL, properties. Okay. Minor thing, since we are using React and we're using on the client, we need to use the use client directive. We have a small issue. Yeah, that HTML. This is an iteration error. Sometimes happens. So this is how we will create the property NFT. So I should be able to create it, right? So let's say Main Street 123, and the bad thing that this is okay. The address, okay, property location, and I'm going to mint it to myself, and I'm going to put that it's 100 square meters. The value, we're gonna use it in money. Let's say it's 250K. That's too much for 100, but let's say 100K. Property type residential, yes, fine, and I'm gonna use a random URL here. Why is this disabled now? Let's take a look. Disabled. It's always disabled. It shouldn't be always disabled. So it's a placeholder, so it's not connected or anything. But we have our UI at least, and I'm just gonna connect it to the Mint functionality, so we can start, thinking on the next session how we're going to build all of these UIs. But I want you to also be able to know how do we connect this. So I'm going to go through the component very quickly. So these are some imports. I'm going to try to keep this as low level as possible, not low level, but like as beginner friendly as possible. But there are some things that might be tricky to understand if it's your first time. Okay. So usually what we have in an interface, in a UI of a website, previously, and if you remember Web 1, Web 2, and Web 3 thing that we discussed in the first session. So Web 1 was mostly static, right? You could only read. So think blogs without even comments or anything. Just like static websites that you could only read as information, read only. So when the shift happened to Web 2, where users could, like this, start modifying, I mean, forms already existed in Web 1, but not with the same prevalence, and not the web wasn't as relying on user-generated content as it is right now. So these kind of reactive websites start to appear, and we start to use more JavaScript on the front end, and that's why we start to get these crazy libraries that some people love, some people hate, but it started to make more useful the components that you can see on the front end. So one of those useful things are state. So right now, as you can see, there is a state, a state in our application, and the form specifically has some state values. Of course, we have some state of who is connected to this app, what is its current balance, what is the value of it right now. That's a state that's being held by the application. And on the front end, we also have a couple of things that are stateful on our form, sorry. So all of these values, at least the way we are handling them, they are currently in a state where this form is filled and it has this information. So if we wanted to modify this and keep track of the information that is stored inside this field, we will need to assign a specific state, similar to what we did in our smart contract, where if we want to keep track of how much balance a user has, we have to create a variable for it, right? So it's similar on the front end. Since we want to hold a value for property location, we want to hold this value that's Main Street 123 because it's important for our application. It's important for our NFT minting. We need to assign a specific state, and that's where the use state hook works in React. As you can see, when I highlight here, it's actually indicating us all of these variables that are being saved inside a state for React. It's a state variable. It's been triggered by the use state hook, and all of these use state has it always returns a tuple. So whenever you call it, you define what is the variable that's going to be stored there initially, and all of these are strings. So that's why you see the empty strings here. And first, you have to. It always returns an array of 2 elements. As you can see here, it's an array of two elements, or that's also known as a duple. So that's like it always comes with these two entities. The first one is a variable. So this is the variable that actually is holding the value. So if I actually start here, hello world, you would see that exactly this is the value that's going to be held initially. Okay, there. If I save, then it changes. See? But we want an empty value. Location, square meters, all of these fields have a state that is being held here. And there are different ways to do it. This is like the simplest one, but that's one way to do it. Then we have imports for components that Scaffolded has created already for us. And the address input, this one's the one that allows us to have these very cool kind of changes between the full address and the ENS. This is a component that's been created by the Scaffolded team. So we are just importing it. We don't have to worry about what is happening inside of the component. That's the cool part about Scaffolded too. If you want to take a look, you are free to do it, of course. Same for the Ether input, which is this one. It allows us to switch value between dollars and ETH very easily. The integer one is also helpful whenever we want to use decimals. This is something that you should probably handle on behalf of your users, not on the backend per se, but on the logic of the component. You could make that switch before sending that information into the NFT or to the contract, yeah, for minting. But for now, we're just using these elements. Okay, so that's what we're doing, the imports, and everything else is just like basic HTML. We're defining some containers, defining this create property NFT title. Yeah, I'm just going to remove this. Small minor thing. And then inside our form, we enter our inputs, which is all the information that we need, and the bottom that says mint property NFT. Great. We need to create a function. And now we're using JavaScript, by the way, or rather TypeScript in this case. TypeScript is this TSX. You can also see, well, it's actually JSX, which is the language that React uses for the components. So that's when you see the TSX. That's TypeScript for React. Sorry, it's a subset or a superset. Sorry, for JavaScript. So that's what we're using right now. It's very similar. It's very similar to Solidity, just a little bit more permissive. You could think of it like that, but we can use it to similar ends. So the only difference is that you definitely have not seen on Solidity is this the HTML tags inside the code. So this is all like HTML. It's for the front end. It's for the web browsers. They're just tags. I mean, it's not really an official. I mean, it's not really a language. It's a markup language, not a programming language. So you're not programming anything. We're just setting tags and defining a structure for our website. That's what it is. And what we are going to do after the AI agent helped us create this placeholder, we are going to define a function as well. And this is the function that will handle the mint function of the smart contract. For now, yeah, we're just going to console log that we are minting the property NFT, and we can assign this function to this button at the bottom that says mint property NFT. It's this one. And we can set on click handle mint. And this is a function that's any button always has this on-click functionality. So we can pass along a function to it. And whenever you click the mint property, now we're getting this console log. Now, everything that we define in this function will be executed whenever the user clicks the mint property function, the mint property NFT button, sorry. And you can see that it's changing here. So we need to connect our smart contract call here. So to do connect mint property function to frontend. And here is where we are going to do a little bit of, where is this? Like this. Give me a second. switch something very quickly. Wait. Until I did this, because it's touch. No. Yeah, no idea why this is happening. Okay. So don't worry. It was just I was wondering why it was getting detected as a smaller screen. Anyways, so now we need to connect this, and we were going to do a little bit of. That's what I wanted to like move here because they already like we're going to do a little bit of cheating because we're going to take a quick look into how the scaffolding team, the build guild team, is actually doing this because they already have programmed all of these calls, read and write functions to their front end. Like if we go to the debug contracts tab, we see that all of our smart contracts have this functionality here. And if we test this mean property on this UI, it's 100,000. So that's what it's supposed to be, residential. And we said that we're just gonna put a random URI. So you see, this is already ready to work for us on this smart contract, on this UI. All right, so here there's a mint. Here's the full transaction. And if I come here and check the property details for token ID 1, here's what we get. So in that case, you would say, hey, let's just take this code and put it into our component. And that's exactly what we're gonna do. So on the debug, and this is a little like funny, not funny, but it's like we're gonna be doing like some drilling of the contracts. So this is a component that's holding all of these full page. So it's including this property NFT, this property shares token, this property shares vault. You see the URL never changes. So this is all under the same route or on the same folder, the debug folder. And it's this page.tsx. However, you see the component is very simple because the debug contracts is all of these components. And at the bottom, they just put this debug contracts, which is this. So we need to go into this component. What is happening here in Next.js, you can import similar to what we were doing on Solidity, where you had a smart contract that you're inheriting from that's outside. You can import it and say, hey, take this contract and make this information available or these components available, this functionality available into this new code that I'm writing. And that's the same thing on JavaScript and a lot of programming languages. You can just import from somewhere else this code and put it into your code. And that's exactly what this is what's happening. This debug contracts component is all of these things. And we'll dive into it because it's doing it programmatically. It's loading from each of these contracts. It's loading this component, which is being repeated, which is the metadata of the contract. This component, which is the variables that are part of the smart contract. All of them have the same elements. I mean, not the same individual variables, but the same components or like definitions. And as well for the read and write methods. You can see here. That's like the structure of the website. So on the code, if we go to the debug contracts, I'm pressing Command and Enter, and clicking it. So I'm going to the debug contracts component, and you see here that we have like also a lot of stuff, yes, but mainly we have two components. Where was that? So yeah, we have two components. We have first this one, that's for the tabs that allows us to switch between contracts, and the contract UI. So we need to dive once again into this contract UI. So first, it's like allowing you to do the selector for the contract and then the contract UI, which is the one that actually contains the methods, which is going to be separated. But once again, we have them here. Contract write methods and the contract read methods. And I'm going to dive straight into the contract write methods because this is the one that I want to go into, the form. And here's how they are actually doing it. So I'm going to go back just so you see how we what I want to get to is this very specific mint property. However, of course, this mint property is not hard coded because whenever you create a new contract, it's going to have different methods. So they are loading these methods from the ABI. That's what's happening here. First, they load all of the smart contracts. So you can see that it's getting it from the contracts data element. That's from this contracts hook that is getting all of the information from the contracts. Yeah, this is a small deviation. But here inside this, first we went to the page for the debug. Then we go to the debug contracts component. Then we went into the contract UI component. And inside the contract UI component, we went to the contract write methods because what's interesting us is the write method for the mint function. And once again, we need to go to the write only function form. And here's where we see how they are doing it. And they're using Wagmi. So Wagmi helps us, if you never use Wagmi, it's wagmi.sh. It's a very cool library that allows us to very easily connect to smart contracts on the front end and call functions, call transactions, get information from the blockchain, get the ENS. There's a lot of stuff here that you can take a look. What's going to interest us the most is going to be the write function right now, the write hook. So here, what we're checking is first, it's getting the configuration for Wagmi from use config. Okay. The Wagmi config. What did it need? Because they're doing like their very cool way to like they are very specific on how to do this. Where's it comes like a sync address function ABI. Perfect. We're not gonna use this, although it's very cool. We could using to pass the Wagmi config and okay. So I'm going to take this function, and we're also going to need this Wagmi config. Copy it and paste it. Oh, we also need the declaration for the use write contract. So let me explain very quickly what's happening here, so you know why I'm doing this. So this component, this very specific form, write only function form, which, if you ask me, it's this block, like the full block that actually this one that actually calls the function. It's contained inside this write only function form. So what they are doing, since Scaffolded is handling the hard hat package as well as the Next.js package, whenever you deploy a smart contract, that ABI gets passed into the Next.js library, or you can into the folder. Only have this ABI and ABI function definitions inside this component. So we don't have that on our component. We need to replicate that part. So we will do it. The onchain is not needed either because the onchain function is so it can detect the changes that are happening inside this element, this input field. The contract address is the contract which you are going to be interacting with. Inherited from, I'm not sure what it is used for. Could be, yeah, not sure. But anyways, you see they are also using use state here. And instead of doing this kind of multi-use state definition, like we are doing here for each field of the UI, here's what they are doing is defining like the object, the complete object here, and it's getting the initial form from the ABI function. So that's how they are able to programmatically define the number of fields and the type of variable and the starting value for each input field. The transaction value, this is just to hold the hash. The transaction. The transaction. This is the amount to be paid. This is only important if it's payable, so we're not going to use this. The chain, this is just to know which chain you are using. The use transactor, this one's from them. Write transaction, make write with params. I don't think we're going to use this. Because this one is more of like, we can use it, but it's like very specific for scaffolding. But yeah, the target network, this is just to make sure that we are on the proper network. And like I said, these are the things that we are actually interested in at the beginning. We're going to import this because it's going to give us like a good UI, a good UX, sorry. So let's first paste it here. And our handle mint, we're actually going to take everything from the handle write function. And I'll explain a bit exactly what's everything. Put it here. Remove this. We can import the use config. We can import use write contract. We can import this transaction receipt, and all of this we can import. There we go. And the errors that we have are here. And the handle mint, we need a couple of things. So first we need the, yeah, this is property species. Okay, no, don't worry. The handle mint, we need to define some things whenever we want to interact with the smart contract from the front end. So things that are kind of obvious is which smart contract you're interacting with. So in the meantime, I'm just going to put like 0x0. The function name is mint property. What happened? Mint property. The ABI, we will, yeah, let's put that like as we had it already. The arguments, we are defining the function signature call, or rather the function call signature. So in our smart contract, if I go to a property nft.sol, our function is called like this. We need to call the mint property, and we need to pass along all of these arguments. And that's exactly what we're defining here. We're telling that we will need to connect to the address, and this we need to replace with actual contract address. Here, we need to enter the proper contract ABI, and we will find it in a bit. Here, we can see that our arguments have been properly, how you call it, placed. And this is not payable, so we don't even need to enter the value one. You can just leave it empty. So we need to create or rather import this ABI, which we have it available. This one should be able to import it. We need to, since this is an async function, I'm not going to go into async functions or this asynchronous behavior from JavaScript, maybe very quick. So the async await thing in JavaScript and of course TypeScript, it's because JavaScript is an asynchronous language. So it just starts off processes and it doesn't wait for the process to finish while it can handle all the other stuff. Wait, no, I'm confusing myself. In JavaScript, async await. Is JavaScript asynchronous? Yeah, it's synchronous by default, but like I said, yeah, it doesn't have it's not asynchronous by default. So if you are waiting for a result such as this, like the NFT, if you send a request to an NFT and you want to execute stuff after the NFT has been properly minted, you need to use async await. Otherwise, JavaScript is just gonna take the next task and execute it, and it's not going to carry. And if you are waiting for that, I don't know, the transaction hash, for example, in order to allow the user to do a following task, you will need to use async await, because otherwise, JavaScript is going to skip to the next task and not worry about it. So that's why we need the async await, because we will be waiting for this simulation to happen and make sure that we don't have an error. So that's why we need it. Then on the make write with params is where we're actually going to call the write contract async. And this is coming from the use write contract hook on Wagmi. So this is how we're actually going to call, and it's called mint. It's not called mint property. Just so we have like a. And then this gets passed. We can import this. No. This is part of a scaffolding, if I'm not mistaken. No, it's not. Let's look for it here. Okay, let me do this. And this one, yeah, I can import. I don't need to call this. If mint property. And now the ABI. And here we do need to check our debug file, because contract UI. Deployed contract data. And but this is only generics. We actually need here contract write. So this is the one that's actually, this should have the information. Yeah. So you see the deployed contract data.abi as ABI. So we need this deployed contract data, which is getting from here. Deployed contract name. Just trying to see where they are getting it from. Contract name. Should be here, yeah, API. So this is very, very, very deep into scaffolding 2. I wouldn't require you to go all the way here. So what we're going to do instead of that, we're just going to use this deployed contract info information. So because I mean, the way that I usually do this is just go to the hard hat and copy the property nft.sol or the required JSON files, and here we have the API. That's the simplest way to do it. You can just copy and paste it. But since we are already using Scaffolding 2, I would rather use what they have created for everyone, so we can actually just very easily eventually just for all of our following UIs get that information as Scaffolding 2 are getting it. So I'm just gonna do this. I'm importing it. Why is this happening like this? Happened here, right? Yeah. NFT. Okay, let's import this first. Fix. Add import. There we go. It's a problem here. Okay. Pending, and let's see. And then we should have it available. NFT. There we go. Here we have just a couple of things that, okay, perfect. What is this missing? We can define the type here. I think that's important. But okay, did that work? We did need this address. That's correct. So that's better. And this is the only one that's missing. That apparently type strings and types of property function name are incompatible. Seems like we're missing. Should have it here. Need property. Yeah. Here. So where's my page? Here. Okay. Okay, let's see what's. It's already late. Yeah, thanks. Got excited with this, but there just seems to be like a very specific issue here with the function name mint property. Unless I'm basket const. Okay. Yeah, there's something wrong with the ABI. I think property NFT because it's not here. It's right only handle right. ABI function that name. Okay. Are we getting this? I'm wondering if it's not catching the. Let's see. Let's console log it. Where is this getting from? ABI function. No, that's okay. On the wrong component here. Should be able to config. Not worked. This doesn't seem to be working. Let's see if we pass just along this. Okay, at least here we get some, but we have some issues here. String that, so now, okay. Was that the problem? I don't think so, but parse. I think you just put begin. I think we should leave it as parse ether, although we risk. Oh yeah, that was the problem. So we were actually doing correctly the property, but we just needed to make sure that we were passing it as begins instead of strings. And we just need to make sure that we are not properties. We are not passing the decimals because we are already parsing the ether. So yeah, let's finish this. So let's say 2nd Street 23. This one is 75 square meters. So it's say $75,000. It's residential as well. And this one's gonna have the Wagmi URL. And we are minting. We are minting from our UI. And perfect. If I go to the debug contracts and I want to check the property details for the recently, Main Street 1, 3 Main Street 3. This is the one. 2nd Street 23. You see, this is the issues of 75 square meters. That's not great. Oh no, yeah, 75, yeah. So this should be 27. So it gets converted into ETH. That's very nice. That's something that's managed by the ETH and this one. So if you enter ETH, it gets sent into, or rather, if you enter dollars, it gets sent into ETH because that's what we need on the smart contract. But yeah, so we finished this integration of the property NFT. We're gonna stop it here because we actually are way over time. We're almost 1 hour. But yeah, so that's how you create a UI using Scaffolded 2 for your specific needs. This is just the first one. We need to complete the flow. That's what we will be doing next week. We will continue with this. The NFT minting was already created. Ideally, we should be able to also see here of the all of the properties available, at least so you can display something. But yeah, so we're gonna stop there for now because if not, we're gonna stay here.
Yeah, you right there at the end, you dove into deep water. That was good though. Yeah, you broke through. Well done. Yeah, Shruti had a couple questions about like what else you can use. What would you recommend for that front side deploying to make it a little more user friendly besides the utilscaf like base pieces that works well as like an opportunity to start with, right? But it looks a little bit like a testing environment. So how do you make it all super pretty and all tying it all together? But I think that's something we could dive into on our next episode. It gives you some good things to think about for Thursday. We can kind of review what you just wrapped up here in this last stretch.
Yes, I think this. I mean, it's more on the. They definitely went for a look. For the components, I'm gonna present again. But seriously, most of the changes that you need, you can do it yourself. For example, colors and all of that should be relatively simple. So let me open the folder, and for that high level styling, you can probably go to the globals file, and there should be some. No, my bad. Here, so we're using Tailwind. I'm not finding the Tailwind configuration. Yeah, there's okay, but it's Tailwind at the end of the day. So for people who are not familiar, Tailwind is just a CSS utility classes plugin or something like library that allows us to very easily create or define styles, inline styles. So instead of managing all of your CSS on a separate folder, such as the global, or a separate file, such as the globals file, you go straight into the element that you want to modify, and you make all of these changes. That's one of the criticisms of Tailwind, is that it bloats everything. As you can see, this very simple div has all of these utility classes assigned to them. So that's where the Tailwind part comes. And that's where you actually can make the changes. So let me see where this definition for the base color is. I don't remember. Styles. Because I didn't see anything on the styles. Color. Okay, here they are. Sorry, my bad. So the colors are here, so you can switch the colors easily in the globals folder. But if you want to make changes to specific elements, you could go all the way to the address input, and I think there's like an input base, here, and you would need to start making the changes here, for example. So maybe that doesn't, you see? Yep. Everything changed here. If you want text white or text red, you enter here. Actually, it should be red. Oh, the prefix. Maybe it's the one on the top. But that's what you need to start experimenting and seeing exactly.
That's where you can go in there and play around and make it look like whatever your heart desires.
Yeah, and it's all around. It just takes the AI just takes what exists currently, so that's why everything's gonna be created like the existing styles. But you can very easily on the none, and it's gonna be like all square. No, it didn't work. Oh, this is for the form, yeah. None. There we go.
Boom, done.
Then you can turn background. Was background yellow if you want it. It should change. Instead of liking it, but because we have it repeated. There we go. But yeah, that's I mean.
No, that's the right advice for sure. Yeah, is that somewhere?
That's how you do it.
Especially if you're managing smart contracts and stuff. This is the easiest way to get these two things tied together from the front and the back, and then you can put the time and the effort into the stylization after the fact. I think that's the right place to start when you're trying to build these things from scratch. Right on, Mel.
Yeah, you want exactly. You want to add more stuff. It's a lot about you exploring. So it's about you clicking here and there. You see properties. I created this. Of course, I knew how to do it before, but small things like this is just about you clicking and diving into the code. It's one of the hardest things at the beginning, like reading other people's code and understanding everything that's happening, especially because there are some crazy. Everybody does things, a little bit their own ways. We all have our own coding style, so this might look as gibberish to you, but that's when you start clicking and say, hey, why this UCNS avatar? Where are they using it for? Okay, so it's from Wagmi, so that's how they use it. Okay, so I can copy this code then and apply it when I like. If I don't like anything, I can just ignore it. But that's how you get better, like clicking and checking. This is something that I will never do. Like I have never had to do this kind of evaluation, but it works. And it also tells you like, hey, if it's like sounds too crazy to work, but it works, like doesn't matter, like just do it. As long as the functionality is there, nobody's gonna check this and say, okay, it works. So who gives? Who cares?
Yeah, you don't have to make all your own Legos.
Exactly. But yeah.
Right on, Mel. This is great stuff. We got a nice solid 2.5 hours to let all this soak in. That's some good success there. That's tail end 2 there. So nice breakthrough. Keep it up. Let's look forward to the Thursday session. We're getting really close to tying that front end and back end together so we can see how it all links up. So that way you can take that idea and turn it into a deployment, and you can share a link with us in the Dabl.chat Telegram group, and we can go dog food it and check it out and see what you guys are building.
Correct. And yeah, for sure. Thanks for staying so long, and I hope you enjoyed these explorations. And next session, I will prepare code beforehand, so we go more into the user experience and the interactions of the smart contract, and leave the placeholders there so you can actually clone it beforehand. I'll try to have it ready for tomorrow. I'll give you a shout, and we can do the final run and connect everything else that's missing, so we can deploy to Vercel and you can start working on your project for next week.
Sounds like a plan to me. All right, friends. Enjoy the rest of your day, and we will see y'all on Thursday.
Thank you, guys. Have a good one.